And as a company, we believe in knowledge dissemination and knowledge sharing. So we decided that we will do a monthly webinar series, largely in the interest of sharing knowledge and information about geotechnical engineering with the community at large. We were thinking about topics, and we thought the first topic that we will address is what is good geotechnics. So we have, most of us understand geotechnical engineering, what it is, soil investigation, soil testing, but many of us still don't appreciate the difference between good geotechnics, good geotechnical engineering, and not so good geotechnical engineering. So we will address this topic today. I do request all of you to please keep adding your comments as we go, put in your comments as we go, and we will take questions during the presentation as well as in the end. So we'll begin now. My name is 𝗬𝗏 Gupta. I'm director of Cengrs Geotechnica Private Limited. We are a Delhi-based consultancy company. Little about our company. We are, again, the company full name is Cengrs Geotechnica Private Limited. Company was founded by IIT Delhi alumni in 1990. And we have a permanent staff of now over 150 people. We publish a lot and so on and so forth. And we also believe in accreditation. So we are accredited with several ISO standards as well. In terms of service offerings, in short, everything to do with soil and foundations is our main domain. We are carrying out geotechnical investigations on a large scale, geophysical surveys, lab testing, geotechnical consultancy, foundation testing, as well as topo and hydrological surveys. In terms of markets, we are very big in energy sector. We have carried out, I think, 80% of the thermal power plants. The investigations have been done by us. We are also very active in the wind and solar industry now, in refineries, petrochemical power plants, nuclear power plants, doing a lot of tall buildings, doing industrial facilities, buildings and factories, bridges, highways, metros, railways, industrial, so on and so forth. So pretty much any structure which we build, which requires, any kind of construction, any kind of foundations, you must go in for geotechnical investigations so you can plan your foundation system in advance. The technical lead of the company largely comprises of Mr. Sanjay Gupta, Mr. Ravi Sundaram, and myself. We are all from IIT Delhi, different batches. I'm the youngest. And in terms of project reach, we are very proud of the fact that we have completed over 6,700 projects in the realm of geotechnical investigations over the last 33 years. So this is a huge database, possibly one of the largest private databases which is available. And we like to say that there's no part of the Indian subcontinent where we have not explored, and we have a lot of information I think is valuable for the construction industry in terms of planning projects and going forward. Let's get into what is good geotechnics. Let's take a simple analogy for those of us who are possibly not from this background. The way you have the human body is like a project. You have different parts of the body, and in that, possibly the heart of every project lies in its foundations. And increasingly, we are seeing that the make or break of a project comes from the success or failure of the foundation system. So again, just the way you need a good cardiologist to take care of your heart and heart problems, you also need a good geoprofessional to take care of your foundation design and to make sure your foundation is performed as per the design. Now again, taking this analogy forward and looking at the analogy with the medical profession, the way you have, simple blood tests, if I'm not feeling well, I can go and get a simple blood test done, get some blood pressure measurements. The same way you have some very simple and conventional investigation tools, largely boreholes, dynamic cone penetration test, plate load test. These are fairly common. However, if I have a more complex medical problem, which cannot be diagnosed by simple testing. We have to go in for CAT scan, MRI, so on and so forth. Same way, if you're building a complex structure, or if you have challenging geo conditions, then you also should go in for advanced testing, cone penetration testing, pressure meter testing, cross-hole seismic testing, so on and so forth. But in this, today we will look at various areas of improvement in what we are doing right now in the state of the industry. We will look at several topics. We look at why awareness is important, and this webinar is part of that process. We will look at the selection process for geotechnical engineers, data reliability, how to define the geotechnical investigation scope, how to select the SI tools. I'm using SI as soil investigation, and geotechnical investigation is one and the same thing. You can look at the importance of good, well-prepared geotechnics, importance of interfacing between the geotechnical and structural engineers, and lastly, we will look at, very briefly, the importance of construction monitoring. Let's start with awareness. And I think this becomes the bedrock of all technical activities, is simply awareness. We talk a lot about, people talk about difficult ground. I get a lot of calls from customers. They're like, "Bhai, mitti bahut kharab hai," or we have difficult soil conditions at this site. And we believe there is no such thing as difficult ground. It's all about knowledge. The way we have, the ground is the same. It's all about knowledge. The way you have it's like a Rubik's Cube, you know. If you have a Rubik's Cube, if somebody has knowledge about how to solve a Rubik's Cube, then it's very easy for them. The world record is under 6 seconds, right? But if someone like me, who doesn't understand the trick of solving a Rubik's Cube, then I will struggle with it. It's the same thing with geotechnical design as well, or civil design at large, is if you associate with someone who understands your problem, who has good experience, then I think problems are not problems anymore, and they'll be easier to solve. We say easy, but I found this cartoon in the New York Times back in 2020. Soil is not that easy either. So there was a cartoon, and this, I believe, is fairly evident as well. If you look at this, soil mechanics is a very complex structure. We have to remember that when you're dealing with the ground, when you're dealing with the subsurface, then you are not dealing with things like, concrete and steel, which are man-made materials with defined properties. When you're dealing with geomaterials, there's a lot of variation, there's a lot of uncertainty, there's a lot of variability, lateral variation, vertical variation. It's a three-phase material. There's so much complexity in this subject that we like to say that geotechnical engineering is a science, but its practice is a bit of an art. You cannot over-analyze geotechnics. You have to have a feel for the soil. You have to feel for the behavior of materials. And that is the only way we can be successful in giving good design, robust design. In this, there are several levels of geotechnical input. And this is a concept which we are trying to promote in the industry, and we are trying to align the decision makers about this. So you have bronze, silver, gold, and platinum levels of geotechnical input. We look at what that is in a minute. The message that we want to get across is that you get what you pay for. Let's look at what are these different levels of geotechnical input. It's very simple. You have, if you are building say a regular G+1 kind of building in competent formation, then and in an area where the geology is well known, then maybe we can go in for a basic bronze level geotechnical input, which can comprise of a few shallow boreholes, limited testing, and you can do a quick empirical calculation, come up with an SBC, and you can recommend a value. Cost of this investigation is fairly low, and it's not very critical either, to be very honest. At the same time, as is the trend these days, if you're building bigger, higher structures, heavier structures, and or if you're building in areas where we don't have competent formations, where the soil is weak, you have geotechnical challenges such as liquefaction, slope stability, or landslide prone areas, then we must move up the value chain. We must look at silver, gold, or even better is to go for platinum level investigations. What this means is a platinum level investigation might comprise of several stages, and we look at this. We might want to carry out several stages of investigation. We might have to carry out a lot of in situ testing, a lot of advanced testing, either in the site or in the lab. The design requirements of such a project would be more involved. The risk is very high. And at the same time, the potential for cost saving is going to be very high as well. And how is the potential for cost saving going to help us? These are slides I borrowed from a friend of mine in Australia. His name is Mr. 𝗵𝗶𝗆𝗏. And he shared this analysis based on a bunch of projects where he showed that as we move from bronze to platinum level investigations, you can actually increase your strength reduction factors. It's better. And nowadays, Eurocode also allows partial safety factors. So as you increase the intensity of testing, the frequency of testing is increased on a project, you can actually build that into your design and you can reduce your ignorance factors and design better. At the same time, as you move up, the cost of investigations can also go down. I always like to share this with clients. If your project cost is 100 rupees, on an average, your cost of foundation is going to be around 10 rupees or 10% of the project cost. The cost of investigation typically is only about 0.3 to 0.5%. That's the market trend. And this 0.3 to 0.5% directly affects the 10% project cost, which is the foundation cost. It's simple as that. So as you do better investigations, as you do better geotechnical design, it is certainly possible to reduce your overall foundation cost. And of course, you also reduce your foundation construction time. Time is money. So this also adds to reduction in cost of the project. And there are several studies. It's not just me speaking. There are several studies which confirm this. This is another study which was carried out in the US, which showed how as you increase the cost of site investigation, there is a reduction in the overall construction cost as well. As another study of the same type, which says that spend just about 1 to 2%. See, the ideal percentage or cost percentage that you must invest in investigations, we should target 1 to 2%. Because if you invest in geotechnical investigations and proper design, then you will get a lot of saving in terms of foundation cost. This is an interesting study, and I want to do a similar study in India as well, where in the US, they asked a bunch of stakeholders, project stakeholders, that what is the amount which they think that they spend on ground investigations, and most of them thought that they spend around 1 to 2%. But when the numbers actually came out, then they found out that they are not spending more than 0.2 to 0.3%. We are seeing similar numbers here in India as well, and I think this is a huge concern, because you have to appreciate that the only variable cost in any project is the subsurface cost. Everything else, the superstructure and all the enabling activities are more or less predictable, but the subsurface cost is the huge variable cost. It is also a variable risk. So the only way that we can reduce cost and project risk is by working on this very, very crucial part of the project value chain. Another study, very briefly, I won't go through the numbers, but just as an illustration of what is possible, this is a project, and we have a paper on this as well. This is a project we did in North India a couple of years ago, where there was an original soil report with the customer, based on which the customer had gone ahead with a design of 550 board cast in situ piles, and the estimated foundation cost was around 44 crores. Cengrs stepped in. We reviewed all the information. We carried out some advanced investigations at site. We did carry out some better analysis techniques. And we also did some initial test piles with dynamic high-strain dynamic pile load tests, integrity tests, and so on and so forth, and bidirectional tests. And at the end of all of this exercise, we managed to bring down the number of piles from 550 to 180, which means the foundation cost went down from 44 crores to 14 crores. Now that's amazing, right? And financial managers would love these kind of numbers. That means that you have an overall project saving of almost 30 crores based on an investment of only 75 lakhs. That's 40x returns. And this is not a one-time thing. We are seeing this over and over and over again in projects where we are getting involved in value engineering. We are seeing a lot of saving being realized, a lot of risk being mitigated on project and day out. In spite of knowing this, the industry is going the other way. This is a cartoon which shows a common attitude among project stakeholders, or some project stakeholders, where they feel that they can save a lot of money by cutting down on the cost of investigation, or even worse, by not doing an investigation at all. Right? That's probably what the guys who built the Leaning Tower of Pisa felt. And you know what happened with that. So that is awareness, and another important aspect is the geotechnical engineer selection process. Right? How do most of us select our geotechnical consultant? How do most of us select our investigation partner? We prepare a BOQ, which is a copy-paste from some previous project. We give it to procurement. Procurement team will email it to pretty much everyone they can find on the internet. They'll collect quotations based on that BOQ. They'll compare and they'll award based on L1 technique. I don't know in what world this process makes sense when you are selecting a technical partner. I don't think it is correct. We have to understand that there is a difference between a soil investigation agency and a geotechnical engineering consultant. Not all investigation agencies are capable of geotechnical analysis and design. So it's just a way, again, going back to the medical analogy, just the way you have diagnostic centers, you have testing testing agencies, and you have doctors. The same way we have soil investigation companies and geotechnical consultants. It's not necessary that both of these are the same. So I do encourage people and encourage owners and project stakeholders not to insist for geotechnical design and for SBC values for every investigation. If you are dealing with a company which is good at collecting samples and testing them in the lab, ask them for a factual data report, and maybe go to a consultant who can work with the structural engineer and the other stakeholders and work out the geotechnical design. And this, on the other hand, if you are associated with a company which is capable of doing both, then great, go with it. But make sure your selection of the agency is based not on L1 technique, but it's based on technical evaluation, based on experience, and based on comfort. We also like to say that, remember I said that these days mostly there's a single BOQ which is just forwarded to a lot of consultants and to a lot of investigation agencies. This is dangerous because investigations, unlike other procurement, when you are looking at investigations, copy-paste job, one shoe does not fit all. We strongly believe that the scope of geotechnical investigations has to be customized, has to be tailor-made for each project separately. And that is the only way to work. So when you have a project, you know where it is coming up. That is the time, the first step of any project should be, you must have a round of interactions with a good, experienced geotechnical consultant who can advise you on what are the geo challenges which are possible in that site. And based on the challenges or based on the available information, based on the data, we must design the scope of the geotechnical investigations for that project. If you have, for example, in a project, if you are suspecting liquefaction, maybe just going for boreholes and plate load tests may not be the best thing to do. If you have liquefaction potential or soils which are likely to liquefy, it might be better to go for CPTs, to go for cross-hole seismic testing. So you get data to help you address those geotechnical challenges. Otherwise, you'll end up, getting one report, getting a second report or a third report, or even worse, you may end up with an insufficient report, which does not apprise you of all the risks involved, and we may end up having trouble later on. Lastly, your geotechnical consultant must be capable of going beyond the codal provisions when the requirement is there. There are many things which are not covered in our design codes, which are expected to be covered by the consultants. If you have artesian conditions, you have dune sands, you have collapsible soils, you have swelling soils, your geotechnical consultant must be capable of addressing these issues and taking care of it. Again, I like to talk about data reliability. We see a lot of students coming out of colleges who are talking about, who are doing their masters and their thesis on all kinds of advanced analysis methods and finite element and Plaxis and Plaque and so on and so forth. While I believe that these are very powerful tools to use, we have to remember that the input data which we put into all of these or any of these softwares is probably more important than the analysis method that we use. And if we don't do that, it's simply a question of garbage in, garbage out. As the first step towards ensuring data reliability, what we have done at Cengrs is we have extended the scope of our NABL accreditation to cover not only all the lab testing, but the entire spectrum of our field testing. Now, this is a very powerful thing because this means that, and we are possibly one of the first companies in the country to do this. This is very powerful because what this means is that each of our tools, if you look at SPT, then that means the SPT hammer is calibrated, its traceability is there, there's replicate testing, and each of these tests which we carry out on site and the data which we use in analysis is verified data. This equipment is calibrated, the data is reliable, and this really improves customer confidence as well as designer confidence. Another thing I recommend that we do, and these days in the era of smartphones is very easy to do. I do recommend if you're getting an investigation done, insist for photographic evidence of each and every step of the investigation. At Cengrs, we have made this standard practice on all our sites, whether the customer asks for it or not. We take photographs which are geotagged photographs with date and time and coordinates. We take photographs of each and every sample, each and every SPT, each and every test, all through the project. So we have photographic evidence, and these are simple tools. You can simply take photographs, you can make a WhatsApp group, and you can ask your investigation agency to share it. These are simple tools to not only understand what is going on, but also to make sure that the process is robust and the data that you get is reliable. There is nothing harm with it. You are paying for the investigation. You must be able to demand for your money's worth. Right. Another thing which we do is, and I think we've gone through several years of finessing these SOPs in our company, is another thing which we do is we have created fairly robust processes to make sure each and every sample that we collect and each and every test that we do is tracked, monitored, audited, and then finalized. So we have created this in our own in-house systems. We have created to check and to verify each and every data point in the field as well as in the lab and downstream as it goes into engineering. And that's how we are so confident about data reliability. I don't feel it is really practically possible to ensure 100% reliability of data unless and until the investigation agency is taking care of all of these point steps and have a system in place for this. So this is simple reliability. I talk a lot about reliability these days because we come across a lot of reports, maybe 9 out of 10 reports that we get, which are carried out by some agencies. We look at the reports and we can tell, and I think you can tell, that a lot of these reports are bogus, they're fabricated, and this is a very, very dangerous trend in the Indian construction industry. We have to all get together to make sure that such fraudulent practices are discouraged, and we have to understand how to catch these practices and discourage them. Another point, and this is a slide, again, I've borrowed from Dr. 𝗟𝗏𝗃 of National High Speed. Another point is when we contract a soil investigation work, we have to understand at least basically what is involved in this. So sometimes we insist for, the report to come in 10, 15 days, and we insist that the work be done yesterday, and we insist for speed, we insist for cheap work, but we have to remember why we are paying. What are we paying for? What we are paying for is to get accurate data. Now you look at lab testing, right? If you have to do one borehole testing, just one borehole testing in 15 days, right? Then you look at this. This is the amount of, you have to have a certain minimum amount of lab technicians available for that project. You need to have a certain minimum amount of lab equipment available for that project. And you need certain minimum amount of turnaround time for lab testing. I come across a lot of cases where, I get a call from the customer. He says that, okay, why are you taking 10 days to do your lab testing? The other guy is giving me a report in just 2 days' time. And my response to them is always the same. I say, boss, if someone can give you can complete lab testing in 2 days' time, give you a report, you need to go back and check, your choices and check your agency to see how it is possible, because it's not possible to do lab testing in 2 to 3 days' time. To help you check on this, for those of you who are not geotechnical engineers, we have also created a small Excel file, and I'm happy to share this file with all of you. There's a small Excel file where you can actually put in your scope of work, and you can ask your geotechnical investigation consultant to actually tell you how much equipment they have available for your project in their lab and how many technicians they have. And this sheet will very simply calculate the number of days that the lab testing schedule will take. And I think this is an important alignment. I do encourage all of you to share this kind of awareness points with everyone, because that's the only way we can catch spurious reports, spurious values, and start cleaning up this industry once and for all. That's a view of a lab. This is based in Noida. And next, I want to talk a little bit about geotechnical investigation scope. This is a nice cartoon which I found. This is very common, when we have conversations, and we usually don't like this. It's almost a negotiation. I don't understand. So several times when investigations are being contracted, we have this kind of a conversation where the owner says that, okay, no, you do only one borehole. You do fewer boreholes. You do it faster. So it's always a tug of war to try to reduce the scope, reduce the time, reduce the cost of investigation. But I don't understand why. We've already seen initially how the cost of investigation is already very small. It's a very small percentage of your overall project cost. We have seen how critical it is and how much it directly affects the cost of the foundations. And C, I don't understand why we want to pay less for someone to do something which is spurious or which is fabricated. Might as well not spend any money at all. So if you do spend money, it is better to spend money on getting correct data, on getting something which will actually benefit your project, instead of just a paper document which goes into a file. This is a risk space. I will not go through this flowchart, but what I'm trying to illustrate to you is that for every project, the process of site characterization has to be very carefully thought through. This again goes back to the previous slide about bronze to platinum level investigations. It depends on the project. Let us stop this copy-paste BOQ system. Every time we have a project, let us assess the risk and then decide, how we want to carry out the investigations, what tools we want to use, which agency we want to go through, who has experience in that area. Sometimes you may not want to go for a single level. So if you don't have information about your site, it might be better to go in for a level 1 investigation where you just carry out a few tests or a few boreholes to get some information about your subsurface conditions. Based on that information, on that initial report, you can then design your detailed geotechnical investigation scope. And that's what the IS code recommends as well, that we do. But right now, we discuss this right now, very often for smaller projects, the investigation scope is being decided by pretty much anyone. It's being decided by owner or the architect or the PMC or the structural engineer. And I feel really that it should be the scope of the investigation must be designed and decided by a good, competent geotechnical consultant. Right? That's the only way this is going to work. It's the same way that a geotechnical consultant should not be defining the scope of the architect or the structural engineer. It's the same way. Right? They're all equal consultants in your project. Very often, because of the way the scope is handed over to investigation agencies, the entire exercise is kind of is doomed even before it starts. Because sometimes, then the investigation agency has got the perfect excuse that, boss, I did what you asked me to do. You are not even asking your consultant to apply their brains, to apply their experience, or to give you inputs. So what are we paying for? Right? Again, there is a lot of outdated testing techniques, a lot of outdated specifications. A lot of these can be updated. We are still living back in the 20th century. We are still relying, our projects have become much bigger in the last 10 years. We are still relying on outdated, obsolete investigation tools such as boreholes and plate load tests and dynamic cone penetration tests. These are good tools and they have their merits, but we must be aware of modern tools, advanced techniques, and we must be aware of the how we have to customize the investigation for each and every site. We talked about this. You can also, for projects which are complex or which have high demand on the subsurface, you can also go in for multi-stage investigation programs. It's a good idea to carry out a desktop study. And we'll talk about this. A desktop study is a very good idea. There's a lot of information which is readily available on the internet, in maps, on databases, with consultants. There's a lot of information which is already available. Right. We talked about how Cengrs has got a database of 6,700 projects. Now, this is a very useful tool and it's there free of cost, available to us. We just have to ask. Right. So a desktop study is a very good idea. Before we do a desktop study, maybe do a site visit, do a site quick recon, visit the site, understand the geology, understand the topography. If required, carry out an initial SI, pick up the data, and then based on that data, design the geotechnical or the comprehensive soil investigation technique program, and then proceed. Even after this process, if you require a confirmatory or peer review report, go for it. We have to remember that our codes have also upgraded. I'm not going to talk about all the codes, but BIS has done a fantastic job, I think, in the last couple of years, where we are also part of some of those committees, where a lot of our old 1980s and 1990s codes have now been upgraded. 1892, which is the benchmark code for geotechnics, has been upgraded in 2021. And the code now gives very good guidelines. This table which I'm showing you is one such guideline. It gives very good guidelines on, basic scope for any geotechnical investigation program, depending on what you're building. If you're building a high-rise building, it says, for example, that, okay, you need to go for at least 3 investigation points per tower. It suggests a 50-meter grade for the other areas. So we must go through these codes, review our codes, and make sure that whatever we do is also compliant with the code. And if required, it should go beyond the code. It should definitely not fall short of the code and basic requirements. The other idea which I say is, when you look at geotechnical investigation scope or geotechnical consultancy, there is actually a 3-step process. And sometimes we end up mixing this. So you have a geotechnical investigation agency, right? The job of a geotechnical agency, just like Dr. Dang or Dr. 𝗟𝗏𝗏 is the job of the investigation agency is to provide reliable, accurate data for foundation analysis. Go to the site, collect good samples, test them in the lab, make sure the data is reliable, and give you a good input, good data report. The job of a geotechnical consultant is to define the scope of such an investigation, is to use such an investigation report and come up with geotechnical design, interact with the structural engineer, do the design, do the back and forth meetings. This is the job of a geotechnical consultant. The third touch point in the project will come when you actually go and construct these foundations. At that point of time, we often carry out a lot of testing of the foundations, also required as per the code. So we carry out, maybe say if you're going for piling, you may be carrying out static pile load test, dynamic pile load test, integrity testing, so on and so forth. At this point of time also, you have to involve your geotechnical consultant or a specialist at this point of time to carry out these tests, understand the test results, correlate it with the investigation data, with the geotechnical designs, and all of these three steps, 1, 2, and 3, all of these three steps must come together for your project to be successful. If we have three different people doing these three different things and they're not in sync with each other, chances are that we'll do something wrong. So in light of this, at Cengrs, what we've done is we are offering all these three services as a one-stop shop. We do carry out investigations, we are qualified consultants, and we also carry out foundation QA/QC. And that way you get a one-stop shop for all your geotechnical requirements of your projects. It's also important for not only in terms of seamless communication, but also good in terms of having a single point responsibility for your foundations. Quickly, let's look at GTI tools. This is a cartoon I use often for describing what soil investigation is. It's kind of what it is. If you think about it, then there is in terms of volume, we are just exploring a tiny fraction of this ground, and we are trying to predict foundation behavior based on these investigations. We have to remember that geotechnical investigation is not about boreholes only. There are a multitude of tools which are available, and all of these tools are available to us, to all of us, for our project. It's not necessary that just conventional boring techniques are applicable for your project. For some, we have to choose which of these tools will apply for our project, and we have to know how to apply these tools for a project for best results. Each of these tests which I mentioned has got its own pros and cons, its own strengths and weaknesses. There is an entire SWOT analysis happening here, depending on which geotechnical parameter is important to us, depending on what kind of stratigraphy we're working in, depending on what kind of geotechnical problem we are trying to solve. Each tool, may have its own strengths and weaknesses, and very often we may have to use several tools in combination and then correlate the results at the end of it. And this is again the same thing. So if depending on what you're looking for, which kind of characterization you are trying to capture, we have to be able to select our tools. And there are several tools which are available. Very often, and this is a common misunderstanding, people think that advanced testing is expensive. I do want to say this now. Very often, advanced testing works out cheaper, faster, and also better as compared to what we are doing right now, conventional geotechnics. So we do recommend, once again, moving to platinum level investigations, particularly for important projects. I think use of advanced testing methods, and hopefully as we go through the year, we talk about some of these advanced testing methods. Adopting these advanced methods has become very important. It's a need of the hour because projects are getting more complex, land is getting sparse, so we are building in poor soils more and more. We do need good specialization, good inputs in order to build without going in for losses, without going in for catastrophic failures. And at the same time, we feel, because given the variability and given the number of uncertainties in geotechnics, we do feel that an increased reliance on field instrumentation data has become very important. For high-rise buildings, for example, now the new codes, IS 16700, recommends, and this is good, recommends settlement monitoring below the raft. It recommends pressure monitoring below the raft. So these are important techniques. Instrumentation will always pay in the long run. It's very important to instrument your foundations, to instrument your construction practices, whether it's retaining walls, foundations, or slope stability methods. Instrumentation is very important. At the same time, once we have reliable data customized to our project, we have good instrumentation data, I think it's also important to adopt advanced analysis methods. We have to move away from simplified, oversimplified, I should say, empirical methods. Move towards, these days we have a lot of tools available. We have, finite element, finite difference tools. We have a lot of softwares which are available. The world is moving on, and we must take advantage of these new techniques. I'm going to keep repeating this. The SI program must be tailor-made, must be customized for a project as per the site project requirements. But in the end, no matter what we do, nothing can replace good engineering intuition, good engineering judgment, and your consultant must have a strong feel of the soil, strong experience of what actually happens in the end. So all of these things will tie up together and you'll get a good product. I won't delve much on geotechnical reporting, but there are several points. I think if you are a project stakeholder, if you are someone who's accepting soil reports, then it's important also that we spend some time. We don't just jump to the page where the SBC is. We should take the time and the effort to go through your geotechnical investigation report, understand whether it is comprehensive or not, understand whether all these points are considered in the report or not. And we have to have a discussion with the investigation agency, challenge them, understand from them, question them, and make sure that the report which you get is robust and it's comprehensive and covers everything which you need for your project. So once you get the report, a common experience is that and we also used to get this, once we submit a report, then we are forgotten. Then the structural engineer, the architect, the MEP consultants, everyone else takes the project forward, and the investigation or the geotechnical consultant sometimes gets forgotten. And I don't see why that is the case. I think we are all, these days, very often on projects, we are working in silos. But I think just the way we have soil structure interaction, having interaction between the consultants, between the designers is very important. In the end, this is a teamwork, right? So all the consultants, all the designers are working together towards a common goal. And that common goal is to give an optimum design translated on the site and build the project within the time and within the budget and deliver it, right? So if we don't work as a team, then I think a lot of optimization, a lot of understanding is lost. It's very important that once the report is submitted, then there should be a round of discussions. It's so easy now with online tools. We don't even have to meet physically. Very important to have a round of discussions with your consultants. Bring your structural engineer, geotechnical engineer in the same room or the same window, and make sure that they go back and forth about the design assumptions, about the loading, settlements, K values, so on and so forth. Right? And this kind of coordination is very important. Next level, once you actually go in for construction, organize a visit by the designers on your site. That's very important because design restricted to paper is not the final design. Right? It's very important. So if you are building, say, a structure, once you excavate for the raft, for example, bring your geotechnical engineer, ask him to come in, look at the strata, bring his report, make sure that everything's matching, everything's fine, and then let him give you the go-ahead for pouring your concrete. That's a good idea. And the reverse feedback loop will also help because everyone grows in the process. Everyone learns, grows, and everyone moves forward as one. While we say this, the last step, remember I said that there is investigation, there is consultancy, And then there is construction monitoring. So the last step is construction monitoring, which is no matter how good or conservative your design is, your foundation which you build at site must be competent. Now, this is something I cannot overemphasize, and I think we will spend an entire webinar separately talking about foundation construction monitoring. This is very important. In India, particularly because we are a growing, developing, nascent economy still, there's a lot of misunderstanding, a lot of lack of awareness about good construction practices. There's a lot of dearth of good skill, good workmanship. And because of that, because of all these factors, a lot of our foundations are not being constructed properly. The workmanship, the last 10, 15 years, I think we have been trying to publicize these issues. A lot of construction defects, a lot of issues at site, and I'm very scared that the number of catastrophic failures that we are having now are only going to increase if we don't take care of these issues and we don't build these QA/QC processes into our projects. If you want to realize your design on the ground, which means that, say if you're giving piles, we have recommended certain metric tons of safe pile load, safe pile capacity. That's just a number, so that number is not going to happen, or those piles are not going to design as per that number unless and until we take care of construction quality. So the only way to do this is continued involvement of the geotechnical and structural engineer throughout the design and construction phases, which means once you get your soil report, don't forget about your geotechnical consultant. Keep your geotechnical consultant in the loop. When you are finalizing your GADs, you're finalizing your design, keep them in the loop when you go ahead and you start your construction, when you develop your QA/QC program. Invite them to your site to come and visit and see the foundations being constructed. Ask them to be involved in either carrying out the pile testing or the foundation testing, or at least in reviewing the pile test reports and making sure that they make sense, making sure that they are as expected. So I think this is one very important thing which we have to do. The other thing is that we can instrument. So I think instrumentation, as we mentioned before, is also will go a very long way in optimizing future foundations. So in case when we are constructing, in case something is going off, and I think instrumentation is already quite popular in tunneling and several phases, but bring it to all our projects. In case something is going awry, in case the foundation performance is not as per expectation, we must get a warning bell well in advance so we can take care of it before things go bad. I want to end with a bit of a mafia offer. We're already 51 minutes through. So we said that, although we said that, every project, the investigation should be customized, I do understand and appreciate that not every organization has got the in-house resources to develop or to design the investigation program in-house. So at Cengrs, what we are doing, and we're doing this since quite some time now, is we have an open offer. If you have a project where you want to carry out investigations, just email us your project location, your site photos, your structure details, and also in case you have any available data, please email it to us. Our email address is given below. It's contact@cengrs.com. Email us your project details, and we have a team in place. We will develop your GTI scope. We will develop your POQ, and we'll share it with you free of cost. No strings attached. We don't even want to necessarily do your investigations. We will be happy to help you with the scope. This is something which we are doing, and it doesn't matter. Beyond that, you can get the work done with whomsoever you want. Not an issue. The second thing which we are offering, and this is our second offer for the industry, is if you have an investigation report or a foundation testing report and you want a second opinion, we invite you to email the report to us. We are carrying out a lot of peer reviews these days. We would be happy to study your report, study your test data, and offer our inputs on the report. And also, if required, we can deliver a peer review report over and above, where we can add some value to your findings. And this is once again, this is a 100% refund guarantee. If you're not happy with our work, we shall, I think, charge a very nominal amount for these peer review reports. So it's a good idea to go for these things. And we'll conclude. I think, hopefully, the target is this year, 2024, we would like to have a monthly webinars. We have planned to carry out these webinars on the third Saturday at 11 a.m. every month. And I think some of the topics which I would like us to discuss would be, we can talk about recent advances in SPT, in pressure meter testing, CPTs, geophysical investigations, cross-hole seismic, so lots of topics to cover. There's less time, so hopefully please stay tuned, mark your calendars. We'll keep updating you on LinkedIn as we go forward, and I do look forward to connecting with all of you as we go forward. Thank you so much. My name is Saurabh. I'm with Cengrs. If you have any questions, you can comment them now, or you can reach out to us directly. We would be more than happy to respond to your questions. Thank you so much.